Yeah, thank you. Orthodox C++, the Vasa has shipped, but who broke the contract? The usual disclaimer to my talks, code is slideware. If there's code, I have personal opinions. I like to discuss them in the break, not during a talk. During the talk, technical stuff. And usually no universal solution. There are always edge cases, and I cannot mention all. And for the geek factor, I don't know for this talk. There is, I think it's for everybody something, but you need to have a certain interest on the topic. Yeah, that's me. The public and the private profile, but it's basically the same. So if you want to know what I do. So now to the talk. Orthodox C++, there was a shipped who broke the contract, and we start, of course, with something totally different. And I start with cognitive load. We all know cognitive load, what it is, how much a brain needs to balance to do a task. And we also know if the cognitive load is too high, errors come in. What is probably not so much known that this leads also to certain behavior issues, right? Oh, the other teams just deliver crap to us, and it can increase stereotyping and other things. But what is this cognitive load? The research suggests we can hold 4 plus minus 1 chunks of information and juggle them at the same time when we do a task. And if it's more, then it's a problem, and that's not a lot. So the question is, how do we even survive? I mean, obviously we do more. And the thing is schema construction. And as example for schema construction is if you take this shopping list, it has a lot of items, and if I would need to memorize them, I would have forgotten the half when I leave the door here. So what we do is we put them into meals. And when I'm at the shop, I just know my 4 meals. And when I think, oh, I need to buy for this meal, then the things fall into place. And this works, and you can, of course, cascade this a little bit. But it's also not a silver bullet, because if you switch from one topic to another topic, through the switch, the context, the cognitive load raises. And you notice you're on your task, you go to the meeting, to another topic, it's something totally different. Oh my God, you get stressed in between and when you come back, and lose a lot of time through this. But the TLDR is we have our limits. Okay, now let's come to the topic, Orthodox C++, and what is Orthodox C++? Who has heard about Orthodox C++? A few people. The rest you should read my blog, because I blogged about it once. But Orthodox C++, sometimes referred as C++, is let's take C and just take a very minimal subset of C++. And that's very popular in some places. And I found this on the internet. It's from 2019, and I stereotyped them, embedded developer and a game developer, because why not? And the one says, hey, what are you doing? Hey, I'm pushing for, I'm adding new stuff to the standards. Why would you do this? There is already everything. I just want to see where the limits are, right? So and that's yeah. That's how it feels sometimes, and this is how a lot of people think about C++ already. So, and this is also maps to something what Björn Strostrup said years ago in the Design and Evolution of C++, which is a book from the 90s. There's within C++, there is a much smaller and cleaner language struggling to get out. And if you think about this book was before 11, 14, 17, 20, 23, and now the upcoming 26, the standard doubled the size. So in proportion, the good stuff became much smaller. But the question is now, of course, what is this? What is the good part, right? Everybody has a different point of view what the good parts of the language are. Some people want to make this object-oriented programming, others want to solve everything in compile time, functional. If we come with people from C background, they do still imperative programming. So what's our C++ that we think is the good subset, and that's challenging. Everybody needs to decide for their own. But this is, of course, interesting. How could you have a team, when you assemble a team, that you have a productive team? Shall they all have the same view, or do you want to have an expert for this and an expert for that? And it can have a huge impact how your productivity is at the end. And if you decide on something, what to use, how could you use tooling to support your decision? So this is interesting questions, I think. Now let's talk a little bit about. I bring a few things and you just quickly raise the hand and then I tell you what I think. So if it would fall for you under Orthodox C++ or not. Ranges. Who thinks that this would fall under the minimum subset? Nobody, seriously. Yeah, okay, it's fine. I mean, we have the fact that ranges introduce undefined behavior in const expression function. There is the talk from Andreas Fertig. If you Google exactly the title, you will find a lightning talk and see const expression, undefined behavior. Should this be not possible? Obviously it is. We had Tina Ulbrich here talking about ranges, where she had a C++, a C implementation and a ranges implementation. The first very reasonable looking ranges implementation was super slow because you needed to know a few details. And then there's, of course, Nicholas Yusuptis with all these talks about ranges and rants about ranges. So, yeah. Why are there also so many alternatives? Tristan Bindel is developing Flux, which is now opting in on the pipe operator syntax, unfortunately, but everybody seems to like it. Google makes, of course, their own stuff, and SyncCell has their ranges library before ranges were in the standard. So, yeah. It's sometimes simple. It's definitely expert friendly and you can run into unexpected consequences. This is my take. Your mileage will vary. So yeah, I'm not sure if I would put this in the subset. Usually I don't need them. There is nothing I haven't had already in the past. So yeah. Coroutines. Orthodox C++ or not? We have one hand up. Two. Okay. Not a third one. No, I mean, who enjoys writing the coroutine boilerplate? I don't think this is, anyone says, yeah, that's awesome. Super intuitive, everybody can understand this. Right? So what to do, write your own one? I mean, it's not that I haven't had this previously already and wait for things. Or shall we wait for senders and receivers? Because the coroutine-based framework don't really come, so it's senders and receivers seems the new one. Or just use a C library, libuv, which runs Node.js, which is battle tested by billions of instances and work callback based, which is probably the fastest you can get, and yeah, you're done, right? So it's definitely not simple, coroutines. Expert friendly, unexpected consequences. I think this is. Concepts. Orthodox C++. Yeah, we have a few hands. Yep. It requires to learn some new syntax, and all the new things you need to learn is on the screen now. So I think actually it is pretty simple to learn. It's pretty simple to explain. And it doesn't mess up anything except that code that shouldn't compile stops to compile if you write the correct concept. So I think this is good. Now modules. What do we think about modules? Yeah, everybody can use them. You have some new fresh experience. You love it, right? I have seen on your posts. Yeah, well, it's a build engineering problem. We don't care at the moment. So, okay, this was 20, right? 23. I just put the print on the screen. Yeah, many hands, yeah, I see also. There is, of course, FMT, and some people said the library, it's so easy to consume, and it develops and maybe faster. But the Hello World example with the print and the format, they are improvement, and it's simple and straightforward. And I think whole 23, no new big picture, a lot of small things, right? There's not else to say about 23. 26, senders and receivers, reflections and contracts. And we don't know because they're not here, right? So let's quickly rush through this. Senders, receivers. Simple, expert-friendly, unexpected consequences. How will it be? NVIDIA donates now the huge library. Will they move on with their own branch? And in 6 years they will say, well, fixed in our upstream, you just need to backport it. Or we will see. And do we really need frameworks in the language? I'm not sure, because it becomes so immortal when it's in the language. It will not go away. So it's a little expert friendly. We will see. I don't know. Reflections, I know, expert-friendly, unexpected consequences. The new syntax is expert-friendly. It's advertised as expert stuff. And the unexpected consequences, at least everybody of you, when this comes into your projects, you will see code you wish you will not have seen. Can guarantee you. And you just need to look how other languages learned to use reflection probably in the past. We can look at this, but it will not protect us. And contracts, we come to contracts in a moment. I just remind, these are the answers of the quiz I had in the intros, small pieces, and a lot of people didn't know about these things. But a lot of people would have known about the big things, right? And I wonder if this balance is correct, because these things make our life easier, while the other things, we probably don't even need them. Everybody needs to decide for their own. And probably we have a little bit too much cognitive load to write code and remember the good parts of C++. So remember the Vasa. Why would I talk about the Vasa? I'm in Stockholm. So we talk about the Vasa. And there is a paper from 2018 by Strostrup, and it's called Remember the Vasa. And it's a fairly short paper. It has just 3 pages, and I would encourage everybody to read it. But I know you will not, or the most will not, so I summarize it up a little bit for you. And it basically says, yeah, there are a lot of contribution to the language, and people work on it, and each of them makes sense in some aspect, but altogether could be dangerous for the language. So that's the direct quote from the paper. And this is also one interesting one. Every proposal is subject to the law of unexpected consequence. There will be unexpected consequences. If something goes into the language, you have millions of users, and you will have use cases you couldn't have dreamed about. And there will be problems. That's just how it is. If you go away from the mathematical ground foundation that Stepanov gave us, senders and receiver frameworks, this is something different, right? And he also recommends work hard on a solid foundation, learn from experience, and don't scrimp on the testing. Yeah, everybody who worked with me knows I very much like this approach. That's my development. And he also says we shouldn't spend most of our time creating increasingly complicated facility for experts. So C++ should be C++. And there is a talk from David Senkel. We had him in our paper club from the standardization of the Swedish mirror. Look at this talk. If you're interested in such topic, it's very interesting. That's just how it is. It reminds us to not put everything into the language. And then question, who knows who said this? Simple can be harder than complex. You have to work hard to get your thinking clean to make it simple, but it's worth it in the end. Any guess who said this? Just a guess. May.
Einstein.
May. No. Okay, I will tell you Steve Jobs. And I think this is it's very hard to keep things simple. It's very easy to make complicated framework solutions. So okay, let's come to the contract topic. A practical observation. For me, as I see myself as a craftsman in C++, not a computer science. So P2900 is the paper that brought contracts into the language. And what is it about? It's about adding 3 new words, mostly pre, post, and contract assert. You put in your check, and if the check fails, you have a violation handler. This violation handler shall be configurable, so you can set it. And then you have 4 modes. Very likely compilation modes, but the standard doesn't know about anything about compilations, so you cannot say is it pragmas, compiler flags, whatever, right? But it's 4 modes. 1 mode is ignore, so don't care about the checks you add there. Observe is make the check and continue the execution, even if the check says, hey, what you're doing is wrong. Enforce is call the handler, which makes sense. You put some log message somewhere and then you terminate, or the quick enforce, you don't call the handler and just terminate. That's the basic idea. And the canonical example, what is always used, is to make something like vector index operator safe, because when people bring up some statistic, a lot of things could be solved by just solving this problem. So that's how the precondition would work. You put it as part of the function signature. The check happens associated with entering a function, and then it's very interesting if you read the current proposals. The check could be evaluated more than once. I'm not sure why some people in high-performance scenarios would want this, but others say there are advantages in doing so. Yeah. Or if we compile it out, then it's not happening at all. We cannot use it to implement operator at, which gives it a guarantee that it doesn't continue to execution, because contract assert can be compiled out, and then this wouldn't happen. So, and this is my greatest critics on this. So why would we want something where we cannot implement the existing safety check in it? It's also not, you cannot solve everything, right? You cannot have a precondition. Hey, do I have limits on my Linux system that I get out of memory order, or did the kernel randomly kills another thread? You need to have other mechanisms in place to check these things. And even if you do this, who would write this code? I would certainly say, hey, for the precondition, yeah, hopefully I get a memory stuff, and for the postcondition I rely on unit tests, because it would also require memory. So who generates the code to remember the old value to test something? And yeah, so we stick for this example now. We will see what else we can have. But the good news is this is not done yet, right? It's a MVP, minimal viable product, as some people claim. And 29 become more that's built up on it, this. And I find it confusing because I don't think this is very minimal. And the relation to standard library hardening is unclear at the moment for me. Just in Kona, they detected a bug in the wording that observe mode for standard library hardening is not very good. So having a check and continue, that's, yeah, so we will see what other consequences are, or if it even is implemented. The existing implementation, they use 4-layer. So if you look at the lib C++ at the moment that has this already, it's 4-layer. You have either the base checks, a little bit more checks, or all the checks, which basically you scale on performance when you have the hardening. We will see what's really coming in there. But for the people who like this, they have exactly a use case in the company. And fine-tuning for a translation unit via flags or some other mechanism is awesome, maybe. I have a problem seeing tooling giving you always this what you expect. It's awesome for documentation. Even if you compile it out, right, you have the precondition documented in the pre, so documentation tool. And then we have also the discussion that probably a little bit stereotyping is going on in this. It's very unpleasant, the discussion on this topic, because there are concerns, and many papers mention problems, and there is not a real discussion possible anymore. There have been long threads, but it's just a back and forth at some moment in time. Yeah, we have these two parties that say this, but we have the unique situation that several national parties might vote with a no if it comes in like it is now. This has never been before, and there are reasons for it. I don't go into the details of these papers. I just show you that the papers exist. If you want to read them, feel free to invest 1 or 2 evenings. There are very well-known people on this paper. Björn Strostrup is one of them who has concerns about these papers. That there shouldn't be in the language like this, and it is not necessarily an improvement of safety. It's also a common viewpoint. We will see if B29 comes into language as it is, we will see enough talks on the pitfall, because we will have the people who go on stage demonstrate how you can shoot in your food, make jokes, and then book a training at my to prevent you from something like this will happen. So we will see. This is the Swedish contributions. The first one is from Jonas Persson. It's basically making contracts reliable by default. This is what it is. So we should at least be able to implement operator at with with this what we get. That I don't think this is a strange desire. The 3849 is the Swedish paper where I said, hey, this brings friction in the community. It's probably there is no implementation experience. It's big. It's not small. Probably put it in a white paper. And then when I talked with, we had an extra meeting. When I talked with people, they said, yeah, you cannot talk to us. You need to write a paper. So I quickly sketched up a paper and said, hey, MVP is this. And this is just one thing. Give me one function I can implement operator add with it and give me a configurable violation handler. That would be a MVP, what I understand as an MVP, but your mileage may vary. Other people have other views. But I put it up. It's not really, I expect that somebody will implement it. Just to give an example. Here are a few more papers. The first one comes from Finnish body. References also Jonas's paper. The second one is from the Spanish. Basically, the whole Spanish national body has signed this paper that they don't appreciate as it is today. And the last one is still a draft. This came up to Kona. It's from Romania. Very well-known people on it, also very well-known companies. They say, make contracts reliable by default, like what we have here and what also. I said already, there should be something you cannot compile out, or deliver everything that you promised for 29, or put it in the white paper. And this one, there is one more meeting in London before 26 goes online. This might get a little bit more discussion, we will see how this goes. For competition, C has also a contract proposal. I guess somebody was motivated by watching what's going on in the C++ world to suggest something for C, and it's more MVP than we have because it has just two modes, ignore or enforce, and the pre and post condition checks cannot have side effects in their wording. We have an unspoken rule, unwritten rule that you cannot have side effects. So yeah, we will see how this flies. There is of course a defense paper from the people. Their pro contracts. Yeah, they list all the points and then they say no new information. We have all the things. They reference to existing papers. Mostly they have written themselves, and they say it will be awesome. And I understand their point of view because they have a concrete use case. The only thing that I say is this use case is not universal enough that it's good for everyone. So why in the language? But we will see what happens. And for the most of the people who actually want contract, it's, oh, if we do not contract it now, then never, right? We tried it already once and we failed. And if we fail again, how will we look? And we need to have some wording for safety and whatnot. Marketing reason. But a lot of people miss the technical background, and it's not easy because you need to invest quite a time to step into what is actually coming into the standard with this and what does it mean and what would be the unexpected side effects you have. And I don't list them today because I just want to keep this generally. But talking so much about contracts, what are these contracts actually? Why is there so much fuss about it? What is this? So where do they come from? And there is this book of historical value, Maya's object-oriented software construction. Maya's created a programming language, IFR. It is in some niches available. I don't know if these companies are happy with it. Object-oriented was a thing in the last century. Meanwhile, no new programming language cares about it. I have the feeling Rust doesn't care, Go doesn't care, SIG doesn't care, Swift a little bit, but it's wallet-based and protocol-based, so yeah. But some people have always a strong feeling to it, and the contracts come in there, actually. And this is a little bit shrinked IFR pseudo-dummy code to fit it on the slide. The usual bank account stuff. You withdraw money or you pay, and you shouldn't be withdraw or pay more than you have on your balance. And these are the contracts, Meyer's contracts. And the invariant at line 2 is the protecting a global state, that this is in a valid range. Then you have 5 and 7, pre and post condition, self-explaining. Then you have for the loop also the state protection via invariant, and the variant is the loop termination, because every embedded developer here knows you kick a watchdog, right? If you don't do this, you assume to hang and you will be killed. So loop termination is a thing, and it's mostly solved actually. And these are the checks that they are require, ensure, invariant, variant, and then there is a check. I'm not sure if this is technically in the academic sense part of the contracts, but this is part of what is introduced in this book and what Eiffel has. And then there are the compilation modes. And the compilation modes is either everything is turned off, or you have a required and you have just a precondition check, or you have the ensured and you have precondition, post-condition, or you add the invariant and you get all 3. With loop you get 4, and with check you get all the checks. And this probably made sense in the 80s because, or 90s, because CPUs were not as powerful as they are today. So, but let's make a little bit of comparison, because what is defensive programming for people? And how does this compare? Because for me, design by contract is the vector. The vector describes you. I want to have from you a valid index. If not, I do whatever. Defensive programming for me is the vector add function that says, you give me index, and if the index is not in the same range, I will stop the code execution. So this is defensive programming. The other is design by contract. Myers knew about defensive programming because this predates design by contract, and he has several paragraphs in his book, and from today's perspective with the security things that happen, they read quite interesting. I have took this one. Defense programming appears in contrast to cover up for the lack of a systematic approach by blindly putting in as many checks as possible, furthering the problem of reliability rather than addressing it seriously. When you read this today, doesn't sound good, and the other paragraphs are much better in this book. So, and we have a wording problem now, right? If people refer to contracts, what do they actually mean when they say contracts, right? Do we have a little bit of semantic damage in the language? Because a vector S has for sure a contract for me, and it's more real than a design by contract, because I can relate from real life, right? Go to a bank and say, hey, I'm compiled now in release mode. the contract I designed for you I don't owe you any money anymore. It doesn't work, right? But okay, on the other hand, we grow trees from top down, so maybe it is, but also no except has a contract, right? A function doesn't throw anything, and you test this with that test, that this is common practice. So we have a little bit of problem when we talk about it, and let's look what the industry actually needs or wants. So defensive programming, visible in code, reliable in production, and actionable on a violation. And I think this is what most people want in their software, especially we, a lot of embedded developer. This is definitely with what we have to deal in the safety world. Design by contract, on the other hand, everything may be ghost code, might be executed or not. We make the log entry and exit, whatever. You cannot see by the code anymore. You need to know the compilation, how they have solved with the tooling. And it's a little bit safety for speed. And I find this a little bit interesting, because if an airline comes to you and says, hey, our planes didn't crash now for 3 years, let's take out a few safety equipments, then we can go faster to the target, and you're traveling with, would you take this airline? I certainly wouldn't. So, but for some type of software, this performance is, of course, the bread and butter. Yeah. But what does the industry really want, right? Rust, assert, it's always there. And debug assert for the things you just want in debug. And it's teachable in 5 minutes to everyone. Swift, precondition, they name it even like this, precondition failure. The one is with the check, the other is just the message that traps. It always executes, it always ends, and assert failure for debug. That's what the industry obviously recommends us to do. And I would expect from C++ to deliver this at the very first step. But we have an MVP that doesn't do it, but a lot of other things, which makes for me no sense. And I apologize to the people that worked hard on this, because I know they did a good job and they tried good things, but if I look at this in this context, I have a hard time to become enthusiastic about it. And this is what code today expected to do. In Rust, you have an index access out of range, you have a panic. Or you configure it and then it traps. And if you have a get, you get an optional. It's there or not, so you don't stop the execution, but you need to check the optional, right? And then for the real stuff where I say, hey, I know what I'm doing, let's go to unsafe. It's very verbose and very, hey, that's the stuff. In Swift, you have the index stuff. If the index is not valid, boom, it's over. There is no safe way to get it, because in Swift you can edit with 4 lines of code for every subscribe operator. And people do this, so they have often the safe with the safe label. But also in Swift you have this very verbose, hey, with unsafe buffer pointer, which is then mostly when you interface with C in a very similar way like Rust has. And we don't have this, and we don't get this, which is a little bit sad, and I don't think that the Misra world will be very enthusiastic about this and say, this will make our safety so much better. I expect exactly the opposite will happen, right? They will say, don't use this, because if you can compile it out, it's not really there. And it would be good to focus first on standard library hardening, getting this right and usable. How does this work in my toolchain? Various compilations, what do I need? Have reliable contract assertion with a custom handler. If my embedded devices crashes, I might put some information somewhere that helps me to find what went wrong, right? So this would be good. And then probably, if I have vector where the index is hardened, and then give me something extra where I can train standard some analyzers or people, if you see this line, be extra careful. So probably this, but we don't get it. So we will get probably something where many of us will have to train Tidy to say, hey, if it's an ignorable contract, please don't compile this code. Or Tidy doesn't compile it, right? The compiler will compile it. Tidy does say, hey, this compilation, you don't want to use it. Yeah, so let me wrap this now up. 1969. An assertion should be used to detect errors as soon as possible. So it's that defensive programming predates design by contracts. Here's also this nice thing. What would we think about the sailing enthusiast who wears his life jacket when training on dry land, but takes it off as soon as it goes to sea? And it's very true. For us in the safety industry, it is true. We cannot take this away. So, and also, this is a very nice paper from Huare. The first principle was security. He's talking about Algol, which was a huge language at these times, and he said, hey, the first principle is security. Every syntactically correct program should give a result or an error message that is predictable. And Algol did a check on the index for array subscription, and they asked the customers, shall we remove it? And the customers back then said, no, please not, because we have catched so many problems. Don't do it away. Yes. But then what's happened to Algol? They wanted to make a subset of the language as the next version. Then the enthusiasts came and make a big language, and then nobody heard about it ever again. So probably we should learn something from this. I don't know. Yeah, and that's already the summary. I kept it very, without going into details. I hope you found something of value. I think Orthodox C++ becomes more and more a thing, even if it breaks my heart, because I was the person who went to embedded program and said, hey, you need to learn the C++ stuff because it brings us so much good. Now it's a little bit more complicated to do this. C++ should be C++, but it's obviously very hard to keep it simple and stick to a solid foundation that leaves no question open. And the Vasa has probably shipped. We will see. Yeah. So that was the talk to this topic. Thanks for